All right, let's talk about something most of us use every single day, but maybe don't fully understand: the car engine. We're going to pop the hood and break down exactly what's happening in there when you turn the key or push that start button.
And yeah, that's not just for dramatic effect. It is literally what's going on. We are talking about thousands of tiny, contained, and perfectly timed explosions every single minute, all of them working together to turn gasoline into the force that actually moves you down the road.
So that's the real magic, isn't it? How can a machine handle thousands of explosions per minute without just blowing itself to pieces? Well, that's what this is all about. It's an incredible story of precision, control, and some really brilliant engineering.
When you boil it all down, an engine has one job, and one job only: turn the chemical energy packed inside fuel into the mechanical energy of motion. Everything else, the entire complicated machine, is built around that one simple idea.
The engine in most cars is what's called an internal combustion engine. And, the name pretty much gives the whole game away. Internal because the fire happens right inside the engine's core. And combustion, that's just the fancy science word for burning something really, really fast.
Okay, so let's zoom in a little bit. We're going to look at the main stage where all this controlled chaos is happening. And you might be surprised at how simple the basic parts actually are.
You've basically got two main players here: the cylinder and the piston. Just think of the cylinder as the arena, this super strong metal tube. And the piston is the main event, a solid chunk of metal that gets slammed up and down inside it. And that fit has to be incredibly tight so none of that explosive pressure can leak out.
So you might be wondering, why not just have one big, super powerful cylinder? Well, if you did that, the power would come in these really violent, jerky pushes. It'd be like thump, 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 not a smooth ride. By using 4, 6, or even 8 smaller cylinders that all fire one after another in a perfect sequence, you get a much smoother, constant stream of power. And that's exactly what you want.
All right, now we get to the absolute heart of the matter. This is the core process that makes the whole thing work. It's a rhythmic, 4-step cycle, like a little dance that happens over and over and over again in every single cylinder.
So the dance goes like this. Step 1, intake. The piston moves down and it sucks in a fine mist of air and fuel. It's like the engine is taking a deep breath. Step 2, compression. The piston shoots back up, squeezing that air and fuel mixture into a tiny space, which makes it way more explosive. Step 3, power. This is the big one. A tiny spark plug ignites the mixture. Boom! The explosion violently forces the piston back down. And finally, step 4, exhaust. The piston comes back up one last time and pushes all the used up gases out, clearing the way for the whole dance to start all over again.
And get this, that entire 4-step dance we just talked about, it happens in each cylinder more than 2,000 times every single minute while you're just cruising down the highway. Just think about that for a second. The speed and precision are just mind-boggling.
Okay, so we've figured out how to create this incredible force that pushes a piston up and down. That's awesome. But we've got a bit of a problem. Your car doesn't hop down the road, right? Its wheels need to spin.
All that incredible power from the explosion is just moving in a straight line, up and down. That's it. And that alone isn't going to get you anywhere.
So here's the next big engineering puzzle we have to solve. How do you take that straight, up and down push and magically turn it into the round and round motion you need for your wheels? Well, the answer is just a beautifully clever piece of engineering. And here is that solution. It's called the crankshaft. The piston is connected to this funky-looking offset shaft. So when the piston gets slammed down, it pushes on the crank and forces the whole thing to rotate. Honestly, the best way to picture it is to think about pedaling a bicycle. Your legs push up and down, but the pedals make the wheels go round and round. It's the exact same principle.
Of course, this whole explosive dance can't just happen on its own. The main parts need a whole backstage crew, a bunch of support systems, all working in perfect harmony to keep things running smoothly and, prevent it from actually exploding.
And there are really 4 big ones. First, you have the timing system. That's the engine's brain, making sure everything happens at the exact right microsecond. Then you need fuel, the food that provides all the energy. Then there's lubrication, the engine oil, which is basically the lifeblood. It keeps all those metal parts from grinding themselves into dust. And finally, cooling, a system that's constantly fighting off all that incredible heat from the explosions to stop the whole thing from melting.
So let's look at that brain a little closer, because it's actually a 2-part team.
You've got the camshaft, which is this old-school mechanical brain. It's a spinning rod with bumps on it that physically push open the valves to let fuel in and exhaust out. But in any modern car, it works hand-in-hand with the ECU, the engine control unit. That's the high-tech computer brain. It's constantly reading sensors and making tiny adjustments to the timing of the spark and the fuel, all to squeeze out every last bit of power and efficiency.
Okay, we are on the home stretch. We've made fire, we've used it to create a push, and we've cleverly turned that push into a spin at the crankshaft. So, now what? How do we finally get that power to the road and make the car actually go?
Well, that is the job of the transmission, and I love thinking of it as a translator. See, an engine has a sweet spot, a certain speed where it runs best. The transmission uses a set of gears to make sure the engine can stay in that happy place, whether you're just starting off from a red light or you're cruising at 70 miles an hour.
So let's trace the whole journey of power, from spark to street. The explosions spin the crankshaft. That spin goes into the transmission, which chooses the right gear for the job. From there, a series of drive shafts and axles carry that spinning force all the way to the wheels. And finally, the wheels push against the pavement and you move forward.
So here's a really cool way to think about it next time you're driving. When you press the gas pedal, you aren't directly pushing the car forward. Nope. All you're really doing is sending a message to the engine that says, hey, I need you to start making bigger, more powerful explosions now. Everything else follows from that.
And that really just sums up the whole thing, doesn't it? The basic idea is almost childishly simple. Make little explosions to push some metal slugs which spin a shaft. The concept is easy. But the execution, making it work millions and millions of times without failing, well, that's just brilliant.
You know, it's incredible to think that this fundamental design has been the beating heart of our world for more than 100 years. It's shaped our cities, our lives, everything. And as we start to look at what's next, it leaves us with this really big, fascinating question. What marvel of engineering is going to be the engine that powers the next century?